Welcome to the lecture series of digital image processing. The topic of today's lecture is fundamental steps in digital image processing. Today we are discussing image processing fields, computerized processes, digital image definition, fundamental steps in digital image processing. Image processing fields basically consist of three broad areas. The first one is computer graphics. In this, the creation of images are discussed. Second one is image processing, in which enhancement or other manipulations of the images are to be done. Then the third is computer vision. In this, analysis of the image content are discussed. Here in this video we are discussing the image processing, where enhancement and the manipulation of the images are discussed. Image processing basically consists of the two things. One is the input and another is the output. When the input is image and the output is image, and the process which enhances the quality of the image, that is called image enhancement. Here we are discussing that when we are doing the image processing, the first version is computer vision. When we are describing the image in the form of computer graphics, that comes under the artificial intelligence. Sometimes image processing is defined as a discipline in which both input and output of a process are images. Means if we are having a block, let's say I'm talking about this block and this is some process, and this is my input and this is my output. When I am talking about input is image and output is image, that type of the processes are called low level processes. We are discussing in details what do you mean by the low level, mid level and high level. But according to this classification, trivial task of computing the average intensity of an image would not be considered an image processing operations. Means that when we want to do the processes on the image, we have to go through either computer vision or image processing or image analysis. But in this curriculum we are discussing the image processing task. First one is the low level process. As I have discussed, in the low level process, input and output both are the images. The operations which are done by the low level process are primitive operations such as image processing to reduce noise, contrast enhancement and image sharpening. These all are the pre-processing steps of any image analysis task. Means that we have to do the noise reduction, we have to improve the contrast of the image, or according to the requirement we do the image sharpening. Again I am drawing the block diagram. Here my input is image and output is also image, and this is called low level process, and this is the task of done by this process are the noise reduction, contrast enhancement and image sharpening. Then mid-level processes. In this, input generally are the images and output are the attributes. Here if I am drawing the block diagram, input is my image and output are the attributes. Attributes are the values, are the some particular values or the axes or the pixel values which are in the form of mathematical form. They are called the attributes, and these are extracted from the edges, contours, identity of the individual objects. So here in the case of mid-level process, input is image and output are the attributes. What type of task done by the mid-level process? Here comes the segmentation. Segmentation is one when partitioning an image into regions or object. When we divide a image into the parts. Let's say this is my image and I divide this in S1 and S2 part. Then description of those objects to reduce them to a form suitable for computer processing. Then classification. Here comes the recognition. So in mid-level we undergo the segmentation, description and classification. The third one is the high-level processing. In high-level processing, if I am talking about the block diagram, input is attributes and output are also attributes. This is high level process where the image analysis part is done. Attribute are the some numerical mathematical values, and at the output we are again getting some mathematical values. The processes which comes under this, the image recognitions, object descriptions, these are the examples of high level processes where we are discussing about the attributes. Then come to the definition of digital image process. An image can be defined as a two-dimensional function f of x, y, where x and y are the spatial coordinates and f is the amplitude of any pair of coordinates x, y, which is called the intensity or gray level of the image at that particular point. X, y and f are all finite values and they are having the discrete quantities. That is why we are using the term digital. Digital, that's why, because of the discrete quantities, it is called digital. Let's say I am talking about the x coordinates and y coordinates, and here I am having f of x, y, and this particular is some intensity value or the gray level value. If I am talking about the gray level values, the values are from 0 to 255. This is my black and this is my white. Okay, the values in between 0 and 255 are called the pixel values or the intensity values. Now we are moving towards the fundamental steps in digital image processing. This is the block diagram of the fundamental steps in which we are discussing all the blocks one by one. The first one is the problem domain. Problem domain means whose image we want to capture. Then called the image acquisition. In image acquisition, how the image is acquired, how the sampling and quantization is to be done, means we are converting a raw image into a digital form. After converting a raw image into the digital form, image enhancement takes place, which is the in which the pre-processing is done, where we are removing the noise, where we are improving the quality, we are improving the contrast, all are under image enhancement. Then image restoration, where when we restore the image, when we restore the originality of the image, here comes the image restoration. Then color image processing, here we are discussing the different color models, and we are having RGB color model and all the processes as we done under the black and white or the gray color images, we are doing in the RGB color images. Then the wavelet and multi-resolution processes, image compression, morphological processes, segmentation, representation and description, and object recognition. These are the fundamental steps which I am going to be discussed in detail, and all these blocks are connecting to the knowledge base. Knowledge base is our computer, means every block is connecting to the knowledge base. And see one more thing, from image acquisition to morphology. See this line. Output of these processes generally are images. Means that here we are giving the input as image and output as image, and these are called low level processes. Fine. And from morphology to object recognition, here output of these from here to here. Output of these processes generally are image attributes. Here the attributes are discussed. So these are high level image processing. So this block diagram is divided into low level processing and high level processing. Under low level processing, we are having image acquisition, image enhancement, image restoration, color image processing, wavelet and multi-resolution processing, image compression, morphological processing. Morphology comes under the low level as well as the high level. If we want to discuss the attributes, then we are not converting the attribute into the images. Then in high level we are having morphological, segmentation, representation and description, then object recognition. So now we are discussing this block diagram into the detail. First is image acquisition. Image is captured by a sensor with sensor like camera and digitized if the output of the camera or the sensor is not read already in digital form using analogous to digital converter. Means at the step of the image acquisition, first we capture the image with the use of the sensor, and that image is converted into the digital form. If it is not in the digital form, it is converted into the digital form by analog to digital converter. Then image enhancement, the process of manipulating an image so that the result is more suitable than the original for specific application. For example, we want to remove the noise, we want to improve the contrast. So these are the parts of image enhancement. The idea behind enhancement techniques is to bring out details that are hidden or simple, to highlight certain features of interest in an image. When we want to show some specific thing or we highlight some specific area of the image, we are using the image enhancement techniques. Or we want to improve the contrast quality, or we want to blur some particular area, or we want to sharpen some particular area, then all the processes come under the image enhancement. Here we studied the filters. Various type of filters comes under the image enhancement. Then image restoration, improving the appearance of an image. When we are improving, we are enhancing, or we are improving the quality of the image, that comes under the image restoration. It tends to be mathematical probabilistic models. Enhancement on the other hand is based on human subjective preferences regarding what constitutes a good enhancement results. Image restoration basically is the subjective preferences, means that it varies from the human to human. The things which I like that appeals good to me, maybe it's not appealing good to any other person. So it varies from person to person perceptions. Color image processing, it uses the color of image to extract features of interest in an image. Here various image color models are discussed. Then wavelets are the foundation of representing images in various degree of resolutions. It is used for image data compression. When the image is represented at different angles to minimize the size of the image, here the wavelets are used. Compression, techniques for reducing the storage requirement to save an image or the bandwidth required to transmit it. When we are compressing the data, we are compressing the images so that they take less space and they use less bandwidth for the transmission purpose. Here we are having the two type of compressions. One is lossy and other is lossless. Lossy means some information is lost, and lossless, no information is lost. Then morphological processing, tool for extracting image components that are useful in the representation and description of shape. Basically, morphologic means the skeleton. When we are finding the skeleton of the image, we extract the image components which are useful in representation, that come under the morphology. Here, when we find out the boundaries, when we find out the missing gaps of the boundary, then morphology is used. In this step, there would be a transition from processes that output images to the processes that output images are attributes. Here, morphology comes under both the categories, low level as well as high level. Here, the input and output both can be images, and input is image and output is attributes that can also be possible. So according to the requirement, if we want output image, then we can get. If we want the output as attributes, that can also be possible. Then image segmentation. When we, segmentation procedure partitioning an image into its constituent parts or objects. When we segment an image, we divide the image, that comes under the image segmentation. When we separate out the object and the background, or we divide the image into the different parts, that all comes under the segmentation, and it is a high level processing where output and input both are the attributes. Then representation and description. Representation makes a decision whether the data should be represented as a boundary or as a complete region. It is almost always follows the output of a segmentation stage. This part, representation and description, is always followed by the segmentation. Means output of segmentation is used as the input of representation and description, and boundary, it is used for the boundary representation and for the region representation. Then representation and description can also be choosing a representation is only part of the solution for transforming raw data into a form suitable for subsequent computer processing. Description is also called feature selection, deals with extracting attributes that result in some information of interest. Then recognition and interpretation. Recognition, the process that assigns level to an object based on the information provided by its description. Knowledge base. Knowledge about a problem domain is coded into an image processing system in the form of knowledge base. So these are the fundamental steps in image processing. Hope you understand this lecture. Thank you very much.